So the example that we'll look at is f of x is equal to x squared plus 5x plus 6. I want to look at this example in particular because the examples that you're going to see, they're not always going to work out nice. You're going to have exercises where they're going to give you not nice numbers to work with, and we need to be able to deal with it. So if I know that my axis of symmetry is going to be a negative b over 2a, using this function, I know that my a value is 1. Remember the invisible number in front of your x squared, and your b is going to be a 5. So when I plug this in, I get a negative 5 over 2 times 1, so a negative 5 halves. I'm going to leave this in fraction form, even though I know some of you are just begging me to turn it into a decimal, but you guys know me by now. I'm not going to do that. So I'm going to plug it back into my function to figure out where my vertex is going to be. I've got negative 5 halves squared plus 5 times negative 5 halves plus 6. So I've got 25 fourths minus 25 halves plus 6. I can get a common denominator, so I'm going to have 25 fourths minus 50 fourths plus 24 fourths. That gives me a negative 1/4. So great, I've done all this work, and now I've got to figure out what it means, right? I'm looking for my axis of symmetry. So if we remember that axis of symmetry is where my function is going to be centered about. So I'm just going to get my little thing on here. It's going to be back here at negative 2.5, right? So here is going to be a vertical line where my parabola is going to be centered, symmetrical about this line. Now the next part is I have to figure out where do I put my parabola, and this is my answer. My vertex is going to have the coordinates of negative 5 halves, comma, negative 1/4. So that means that it's going to be right here. There is the vertex of my parabola. If I think about which direction it opens, I know it's going to open up because my a is a positive number. And now I just have to figure out the rest of it. And do I really want to just plug in a bunch of points? I don't want to plug in points. I don't want to make a table. So instead, I'm going to see if I can figure out a couple of extra points that I could put on here to help me determine exactly where to place my parabola. The next thing that I'm going to be using is I'm going to look for my x and y intercepts. So remember, your x and y intercepts are the places where it's going to cross my x-axis for my x-intercepts and my y-axis for my y-intercepts. We found these before with different functions. We found them with linear functions mainly. So let's go ahead and remember how we do that. Remember that if I want to find my y-intercept, that means that it's going to be on my y-axis. And if I'm on my y-axis, the coordinate of my x is going to be a 0. So in order to figure out what my y-intercept is with the function that I'm dealing with before, I'm going to need to figure out what f of 0 is. So I'm going to plug in a 0 squared plus 5 times 0 plus 6. So I get that my y-intercept in this case is just going to be a positive 6. So coming back up to my graph, 1, 2, 3, 4, 5, 6, there is my y-intercept. That's going to be the one that's always the easiest to find. The one that's harder to find, however, is going to be our x-intercepts. And if I'm dealing with my x-intercepts, that means that I'm somewhere on this x-axis. That means that the coordinate for my y is going to be a 0. So that means that for the function that I was just looking at, my function, remember, it's y equals x squared plus 5x plus 6, I'm going to have 0 is equal to x squared plus 5x plus 6. This is where everything that we've been doing the last week or so is really going to come into play. I have to solve this quadratic function, or this quadratic equation. I have to figure out what x is equal to. So this one, if I'm looking at it, can I factor it? I don't think does it factor? Oh, it does factor. If I can solve it by factoring, that's going to be my best route. And this one factors, I know that I need to have a product of 6. It's going to be a 2 and a 3 to give me that sum of 5. So I can use my zero product property. I know that x plus 2 equals 0, x plus 3 equals 0. So I've got x is negative 2 and x is negative 3. So those are going to be my x-intercepts. Going back up to my graph, I can just plug them right in. And now I can create the shape of my parabola, because now I have those important features played out. Now this looks like it's a little too skinny here. If I was on actual graph paper, I can do a little bit better, and I'm going to do one on graph paper here in a minute. So let's take a minute and review what it is that we are looking for when we're dealing with those important features of a quadratic. Let's make ourselves a list so that we know what to do. The first thing that we're going to do is we need to figure out, does it open up or down? That way we know what it is that we're looking at. Is it going to be one that's going up like this, or is it going to go down like that? And remember, we look at A to tell us that. The next thing that we're going to find is our axis of symmetry. And remember, it's going to be that vertical line with the equation x is equal to negative b over 2a. Remind yourself to make it a dotted line. We want to get in the habit of anything that's not actually part of our function, it's a dotted line and not a solid one. That way we know it's just a feature of our graph, not necessarily part of our graph. The next thing is we need to find our vertex. That vertex, remember, that's either the maximum or the minimum. And in order to get that, we plug in our axis of symmetry for x into the function. And then when we can figure out where to put it on our axis of symmetry. The next part is we find our x and y intercepts. And some of you might be feeling like maybe it's just easier to make a table, because with a table you can just plug in points, but it's not always going to give us those pieces that we need. When we are graphing a quadratic, these are the things that we need to know. And it would be a lot easier if I can just find these rather than just happen to have them show up because I graphed them nicely. If I have x and y intercepts that are maybe not nice ones, maybe my x-intercepts are not negative 2 and negative 3, maybe there's something in between. They're things that are a little bit harder to see on a graph. I'm not necessarily going to just put those into my table. So I want to have methods that I can find them, because these are the important things that we're going to be looking for. So let's go ahead and look at another one. Let's see if we can graph it. I'm going to switch over to graph paper here so that you guys can see a nice pretty graph. So let's look at the function f of x is equal to, let's look at 2x squared minus 2x minus 12. So for this one, the first question is, does it open up or down? And I'm going to need to know what A is. A is a 2, so this one opens up, because it's a positive, so I know it's going to be opening up. The next thing I'm going to look at is my axis of symmetry. Remember, x is equal to negative b over 2a. So for this, my a is 2, and my b is, remember that negative belongs to that number that's out in front of it, so it's a negative 2. So I've got a negative, negative 2, all over 2 times 2. There's a lot of 2's. That becomes a positive, and one of my 2's cancels, so I have a 1/2. Oh, darn it. Another one with not nice intercepts, or not nice axis of symmetry. But that's okay, because we know how to deal with this. And if I look at my function, with this one, I'm not really afraid of plugging in a 1/2, because I've got so many things that it's just going to work out nicely with. So the next thing I've got to do is find my vertex, right? So my vertex, I'm going to take this and I've got to plug it into my function. So f of 1/2, I've got 2 times 1/2 squared minus 2 times 1/2 minus 12. So this is going to be 2 times 1/4 minus, these are going to cancel, so I just get minus 1 plus 12. 2 times 1/4, that gives me a 1/2 minus 1 plus 12. So that is going to be, I've got 11 plus 1/2, so 11 and 1/2. If you want to do it as a mixed number, or it's going to be 23 over 2. So I now have the coordinates of my vertex. My vertex is going to be at 1/2, comma, 11.5 or 23.2, however, or 23 over 2, however it is that you want to say that. The next thing that I need to find is my x and y intercepts. My y-intercept is the easy one. Remember, if I want to find my y-intercept, I set x equal to 0. So I'm going to plug in a 0. F of 0 is equal to 2 times 0 squared minus 2 times 0 minus 12. F of 0 is equal to, this is 0, 0, just a negative 12. In case you haven't noticed, my y-intercept is always going to be that c if my function's in standard form. So I've got my y-intercept now, and the next thing I need to do is figure out what my x-intercepts are. And that means I need to set y or f of x, because remember those are interchangeable. I need to set y equal to 0. So I've got 0 is equal to 2x squared minus 2x minus 12. So for this one, I'm noticing if I want to solve this, the first thing I want to do is I want to get rid of these 2's. I want to make this a little bit simpler for me to look at. So I'm going to have an x squared minus x minus 6. Because everything here was divisible by 2, I could divide both sides of my equation by 2 to make it easier. And then this, I can actually factor. They're not all going to be factorable. Sometimes you might have to, if you want, complete the square. Other times you might want to use the quadratic formula. You remember using those techniques that we did earlier. This one does factor. I'm going to have a plus and a minus because my product is negative. I'm going to end up using 2 and 3. I need a negative 3 and a positive 2. So using that zero product property, I've got x plus 2 is 0 or x minus 3 is 0. So I have x-intercepts of a negative 2 and I've got an x-intercept of a positive 3. So now it's time to get all of these features onto a graph. I'm going to get my graph here so we've got something to work with. The first thing I know is that my axis of symmetry is at 1/2. So I'm going to go ahead and add that to my graph. Remember, that one's a nice dotted line. And now I need to get my vertex on there. Oh, I messed up my vertex. See, this is why I need you guys here. I missed a negative. This should have been a negative 12. And this was a negative. So it's not 11.5. It was actually a negative 12.5. It's going to be a very long couple of weeks without you guys here to find my mistakes. So we will do our best. Eek. So I'm actually going to, do I have enough room down here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I do have enough room. So I'll still be able to get it on to my graph there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5, and then 1/2. Right here is my vertex. And I want to label these points right here. So I've got 1/2, negative 12.5, negative 12.5. The next pieces that I can get on here is I can get my y-intercept. My y-intercept is a negative 12. So 0, negative 12. And then I've got a negative 2. And I've got a positive 3 for my x-intercepts. So this point right here is 3, 0. And then this point right here is negative 2, 0. So now I can go around and I'll do my best to make this pretty. But we'll see. Notice this one is steeper. We'll look at that a little bit more when we're doing section 9.7, dealing with, the shape of parabolas and transformations. But today we're just looking at the basic graphs of them. There we go. So there is a graph of a quadratic. We're also going to be looking at things called maximums and minimums. And remember, that deals with our vertex. If you look at this graph, the minimum of this function, the lowest it will ever go, is this point right here, my vertex. It's going to go down and then go back up away from it. So this function will never go below a negative 12.5 for its output. We've looked at one that goes the other direction. Grab it here. And that was this second one that we did. This one, it's going to go up to where y equals 1, and then it's going to come back down. So it's never going to have anything up above here, so this is the maximum. If you're looking for the maximum or the minimum, all that you're looking for is your vertex. Okay? So I am going to give you time to work on these now, and if you have any questions, you can email me or add it to the comments, whatever you want to do. And hit that like and subscribe button. I will talk to you later.